Today's presentation is on conscious spatial decision-making with context-independent technology. I'm Steve Ferenger, and my colleague Salvatore Garofalo are from the City University of New York. We are presenting at the Jean Piaget Society Conference, June 2nd, 2021. Modern technology has changed the way in which people interact with knowledge. The global community has embraced technology as a medium to enhance the human experience and to automate one's life as a means to complete tasks such as navigation. Our concern is that there is a potential imbalance toward digital environments that may lead to poor transfer of spatial skills in the physical world. In this investigation, we study the hindrance of one's spatial navigation ability due to their reported dependence on geographic information systems. Specifically, is there a relationship between non-interactive, context-independent technology and spatial ability? In the present study, participants provide responses to how they would get and give directions. Comparisons were then made with the National Survey of Navigation Application Use by participants. The authors framed the study through a neuroconstructivist lens to discuss the interplay of intrinsic biological and extrinsic environmental factors which interact under a system of constraints on neural structures that affect neural activity, and in turn, the induction relationship of neural activity on mental structures. The reciprocal relationship between neuron structure and neural activity are thought to be mediated by an experience-dependent mechanism, which can be influenced by the environmental press. Therefore, further research should examine the neurological and physiological differences due to increased use of non-interactive, context-independent technology. On the screen in front of you, we can all see the ubiquitous mobile device that provides us with constant information, both communication information, navigation information, and other types of communication. When we take a look at the following four photos, this could be an example of what might be thought of people who rely specifically on strip maps as mental models in their mind of how to get from point A to point B, where they are just in the vehicle and they are being directed by the navigation device, which is technically doing all the thinking, but perhaps not doing all the thinking correctly for the individual. So in the photos, as you can see, when people sometimes wonder, how could that person drive off the cliff? How could that person drive into the ocean? How could this individual be wandering the Southwest deserts, okay, where there are no roads? How could somebody continue in their travels across a road that has not been yet completed? The most popular navigation devices are listed on the slide above. Clearly, we could see that Google Maps are the most popular, with MapQuest being the least. We are also concerned here by how these apps are primarily used. According to a 2016 study by the Pew Research Center and a survey by Manifest Consumer App Survey, stated that about 90% of smartphone owners use their cellular devices to obtain directions and other location-based information. Location-based information was found to be a common mobile phone function among all age groups, from young adults to the elderly. This demonstrates a clear replacement of traditional wayfinding methods with non-interactive, context-independent technology. Some would argue that the current dependence on navigation apps limits independent critical thought, as evidenced by anecdotes of individuals blindly following voice commands to their demise, something that we saw in the previous slide. Can GPS apps diminish spatial coordinate reasoning and orienteering? In the national survey, 36% of navigation app users looked up directions prior to leaving. Another 34% use navigation apps while they're en route, and 30% use them both prior to leaving for their destination and while traveling to their destination equally. How else do we use navigation apps? 90% of the apps are used for driving directions. However, there's another 10% of the population that are left. Of those, 24% surveyed use navigation apps for non-driving directions. However, this is only for individuals who lived in the Northeast. People in the Midwest use it 12% of the time, and people in the South 8% of the time. It is interesting to note the geographic differences in use of navigation apps. In the present study, we asked participants how they prefer to get and give directions. Then we also gave them a spatial abilities test, and we looked at two scales in particular, coordinate reasoning and spatial orientation, believing that these two scales within the spatial abilities test probably would most closely be skills that were necessary when getting and giving directions. The descriptions of the participants in the study are listed on the slide. And we had two groups, basically biology students and chemistry students. All were non-drivers, and it is important to identify that this is a homogeneous group. They are all males, which does limit the extrapolations that we can make from the present study. So when we look at navigation preferences for chemistry majors, when getting directions, approximately 7% would prefer to use a map, 14% would prefer to be told, 79% would prefer to use an app to navigate. That means to fully navigate. So when we're talking about here in the present study, when we said they would prefer to use a map, they would either use a physical map, draw a map, place landmarks on paper. All of that would be considered using the map. Those that wanted to be told were basically using some points of auditory memory and having certain memory points of location in those auditory directions. And those that used GPS, they were using it for turn-by-turn directions. And they let basically the app do the work. In giving directions, okay, almost 5% would prefer to use a map when giving them, 40% would prefer to be told, and approximately 55% would prefer to use the navigation app. For biology, you can notice that we had to condense, okay, the three categories from maps, physical maps, to auditorily being told the directions, to using GPS for turn-by-turn directions, because these participants did something very interesting to the surveys. They literally wrote on the survey and added something else. They would also prefer to, when giving directions, to text the directions to the individual, and when getting directions would also like to be text the information. So for these candidates in getting directions, 26% would prefer to use a map or be told or to have it text to them, while 73% would prefer to use the app to navigate. In giving directions, 45% would prefer to use a map or text the directions, and approximately 55% would prefer to use an app to navigate. And as we said before, it was very interesting because the text response that we did not have on the survey was only something that biology candidates had put down on the survey, literally wrote on the survey. We don't exactly know why, but that's something further to investigate. Our finding for the chemistry students, we had no significant difference in the overall spatial ability scores and scale scores for the manner in which participants preferred to either get or give directions. However, this was an interesting caveat. There was a significant difference in the observed values and the expected values across the three categories for how participants preferred to get and give directions. Therefore, there was a difference for how they preferred to get and give directions. It was not the same across the categories. For the biology students, there was a significant difference in the overall spatial ability scores for participants who reported no use of an app for navigation, compared with those who did use an app for navigation. Also, like the chemistry students, there was a significant difference in the observed values and the expected values across the two categories for how participants preferred to get and give directions. Again, we still don't know why this was so, and greater follow-up is going to be needed. But as we said, we did find it across the two groups, similar for chemistry and biology participants. There was also a significant difference found between the overall spatial scores of chemistry and biology participants. Chemistry students had a higher overall mean score for their spatial abilities test as opposed to the biology students. Any extrapolations from the findings have to be carefully considered due to the homogeneous population sampled and the stratification of the students who were attending the private school. Similar to the national study, the majority of participants, 76%, preferred to use an app to navigate when getting or giving directions. Biology participants who had higher spatial scores also used less technology or reported using less technology for navigation. Overall, there was no conclusive evidence to suggest with certainty that app use hindered spatial ability across both biology and chemistry disciplines. Additional research with a broader population is required. As I mentioned earlier, we also have to note that this was a stratified group of students who on their entrance test have a spatial abilities test that is also used for selection. So again, the group is stratified on a number of variables. However, it is clear that prior to driving, participants have a preference for navigation apps when getting and giving directions. It is also evident that the participants overwhelmingly used Google Maps for all their navigation needs. Biology participants had a propensity to text directions when getting and giving directions. And this was something that was not on the survey instruments, but that the biology candidates actually had written on the surveys when they were collected. It is also interesting to note that participants had a clear difference in how they preferred to get and give directions. This was something that we did not anticipate, and we expected that giving and getting directions would be similar for both groups of students. The following are some of the references that we used in order to complete the investigation and to develop today's talk. Our contact information is listed on the following slide. Again, I'm Steve Ferenga, and my colleague Salvatore Garofalo. We can be found at the City University of New York, Queens College campus. Our emails are listed below. Thank you.